in the quiz we had an exponential distribution, right? It was like a kind of discharging of a capacitor on a resistor. There are different types of let's say different types of distributions, and today I want to focus on the normal distribution. Okay, for example, let me share with you my MATLAB screen. Okay, here is my MATLAB. Maybe I should share the whole screen so that you're going to be able to see. You're going to be able to see the plotting. So now here in a round n 1 to 1000, it generates a normal distribution, random variable, random numbers, 1000 random variables or numbers, and assign it as A, and you can plot the histogram. Let me plot it again and show you what is the distribution of this round n function. Round n function generates the mean expected value of being 0 and variance being 1. Okay, so if you increase the number of points, for example, and plot it again, you're going to see that like the shape is still a kind of bell shape. Okay, this bell shape structure is characteristic for the normal distribution, also called Gaussian distribution. Okay, so you may change the number of points. For example, if you want to change the mean from 0 to 50, here is how I should do it. Okay, I'm gonna generate 10,000 numbers, and then I'm gonna add each number 50, and then now I'm gonna plot the histogram again. Now the mean is 50. Okay, that means the distribution is around 50. 50 is my average number, and still the variance did not change. You see, the variance, the spreading of the data points have not changed too much, right? So if I want to change the variance, I should multiply it here. If I multiply each number by 10 and add 50, then if I want to plot it, okay, now the variance have increased. You see, it was like between 47 and 53. Now it is between 15 to 90. Okay, you can see that now the data points are more spread, and mean have been moved to 50. So I'm going to start talking about these concepts of normal distribution. Okay, I'm going to start with the discussion on normal distribution. Let me share my screen at this point, and then start talking about normal distribution first, then discussing the basics of statistics. Okay, so here is my screen, and then I'm going to take it out like that. So what did I show you just a couple of minutes ago? I have a distribution like that, a bell-shaped distribution. There was one mean value. Okay, this is mu, which is mean, and there was this sigma value, which is the variance or standard deviation. Okay, sigma is the standard deviation. What does the meaning of variance? How spread my data around the mean? Okay, here is the PDF of standard Gaussian or normal distribution. Okay, you will see this a lot in your career in telecom, in other parts of the electrical engineering fields, like normal distribution or Gaussian distribution. Okay, it's bell-shaped. Normally, if you have this PDF, the mean is 0. Okay, the mean is 0. Okay, mean is 0 as pointed out here. Expected value of this z is 0, and the variance is 1. Okay, variance is 1. Either you show it by normal distribution, 0 mean, and one variance, okay? And your random variable is z, okay? So here is my...
Then how do we get the variance from the plot?
We don't get it from the plot because you have to see it from here, okay, Emmanuel? For example, if you see z squared, then it means, and there is nothing here. Please take a look at this one. Let me show it here. If you see such a PDF, okay, then you're gonna see the mean in the PDF and variance in the PDF, okay? From your data, for example, you have your data, okay? I gave you certain data points, and the histogram is something like that, and mean is 50. How do you determine the variance? What was the definition of the variance? You take each data point, subtract the mean from each, and then take the square, okay? Add all of these data points. Let's say I have 100 data points, and then divide by 100, okay? That's how you determine the variance. So you take each data point, subtract it from the mean, take the square of this difference, and then add everything up, and then divide by the number of additions you did, okay? That is my variance. So how big is the difference between your data points and the mean will really constitute the variance. For example, if you have 1, 3, and 5 as your data points, what is the mean? If you have 1, 3, and 5 as your data points, what is the mean? 3 is the mean, right, guys? 3 is the mean. How do you determine the mean? 1 plus 3 plus 5 divided by 3, which is 3, right? How do you determine the variance? 1 minus 3 squared plus 3 minus 3 squared plus 5 minus 3 squared times 1 over 3. Why do you do 1 over 3? Because you have 3 points. And the probability of obtaining 1 or 3 or 5 is the same. Okay? So that's why I do this 1 over 3 times this. Okay? So this will be 2 to the power 2, 4. 3 minus 3, 0. 2 to the power 2 to the power 2 is 4 again. So the variance is 8 over 3. Okay. How about if my number is like that? I'm gonna have 3 as my mean again, but this time I will have -1 and 7. The numbers are 1, -1, 3, and 7. What is the variance? Mean is still 3. 3 plus 7 minus 1 will be 9. Divide by 3, it will be 3, right? Mean will be 3. What is the variance? -1 minus 3 squared plus 3 minus 3 squared plus 7 minus 3 squared divided by 3. What is the value here? It will be 4 squared plus 4 squared, which is 16 plus 16, 32 plus 3, 32 over 3. It was 8 over 3 here. Now it is 32 over 3. So you see that the data points are away from your mean, your variance will increase. Okay? Is this clear? For example, let me show you one example like that. Here, the variance is 1. Okay, or standard deviation is 1. Here the standard deviation is 2. You see, it is much more spread. It is much more spread around 2. Okay. For example, you can shift the mean from 2 to -2 like this. Okay. You keep the mean as it is. You change the variance. You see the difference, guys, here? You see the difference of these two? There is one more spread distribution. There is like more sharper distribution. This is a sharper distribution. This is a more spread distribution. Why is that? Because the variance has increased by 2. It was 1, now it is 2, right? If it is 2, that means it is more spread. So normal distribution has the bell-shaped curve. The PDF of the normal distribution is this. It's called standard Gaussian distribution. Why is it called standard distribution? Because here mu is 0 and standard deviation is 0. Okay. If you want to have it a general Gaussian distribution, you want to have a general mu, which is going to be your mu 50, 10, or something other than 0. And you may have not 1, sorry, not 0, 1. Standard deviation is 1 here for the standard Gaussian distribution. For the general Gaussian distribution, we have mu and sigma other than 0 and 1. Okay, then it's called general Gaussian distribution. You're going to see this a lot. Okay, you don't have to memorize it for the time being, but you can see that there is like x minus mu here. You see this is variance formulation divided by 2 sigma squared and e to the power, something like that. Okay, so what's my PDF? Let me write it like this: 1 over sigma root pi times e to the power minus x minus mu squared divided by 2 sigma squared. Okay, that is the general PDF Gaussian distribution. So we will have a standard Gaussian distribution with 0 mean, 1 standard deviation. We may have another distribution which is going to be general Gaussian distribution. The mean can be 2 and standard deviation can be 1 or 2. If it is 2, then it's going to be like this, right? The standard deviation is going to be increasing. Okay, so this is the basic idea behind the Gaussian distribution. Now we are going to do one example which is critical here. Also, let me stop sharing this, and I want to show you one. Let me show you one. Sorry. Okay, this is something that you are going to use from now on. It's called z-score table or z-table. Okay, you see x minus mu divided by sigma. It's the normalization. I will talk about this. And then you will have that kind of a distribution, okay, which is 0 mean and 1 standard deviation. And then we will be able to find out the probabilities, okay, standard normal probabilities. For example, what it would be the probability of obtaining a number which is less than minus 3.3. Okay, can you see that, guys? Here you see that there are numbers for each and every z value. You see here minus 3.300, 3.31, 3.32, 3.33, and you can see the probabilities of obtaining such a number. Okay, let me come here again and show it on my screen again here. Okay, let me show you here. Okay, so we have a distribution like that, and it is, let's say, 0 mean and 1 variance. if I want you to find out the probability of Z, okay, this is PZ, probability of Z being less than minus 3.3. What does this mean? This is minus 3.3, and the probability is the area under this curve, right? PZ less than minus 3.3. So this is the area to the left of this 3.3 number. So this area is corresponding to the probability of Z. Okay, probability of Z less than, so this shouldn't be there. Let me do this again. So probability of Z being less than or equal to minus 3.3. Okay, so we use a Z table. Okay, Z table, you can find it everywhere, and in exams I will give you the Z tables. Okay, it's immemorizable. It's like finding the output of this PDF integral using a table. Okay, that's what we do. So if you want to find out the probability of obtaining Z greater than 0, then it is half of my PDF, so it's going to be 0.5. The probability of Z being less than 0, again 0.5. Okay, here is the area under this curve, whose area under the curve is 1 because it's a PDF. That's the rule for PDF. The area under the PDF curve should be equal to 1. So the area under this curve is always 1. Area under this curve is always 1. So we are trying to find out what would be the area under this curve, okay, for a number Z, okay, greater than this Z or less than this Z, okay? And we check the Z table to find out the probabilities. So we will do some examples right now. Maybe it's the first time you see this kind of a thing, and give yourself some time to understand the logic. Okay. For example, here is one example here. Let X equal to the IQ of a randomly selected citizen. Okay, and assume X is distributed according to the normal distribution, whose mu is 100 and whose standard deviation is 16. Variance is 16 squared. You know, standard deviation, and standard deviation square is variance. Okay. So that means my distribution is something like this. Normal distribution. Mean is going to be 100, and standard deviation is going to be 16. Okay, this is Z. So this is IQ. And here is the question. What is the probability that a randomly selected citizen has an IQ below 90? What does this mean, below 90? I have this 90 as my threshold, and I want to find out the area under the curve below 90. Did you understand how I came up with this area under the curve thing? So it asks me probability of X being less than 90. Okay, so that's the question. So I have a distribution whose mean is 100 and standard deviation is 16. This is found out from many, let's say, tests run across the world, and this is what we found. And then what does this question ask me? What is the probability that a randomly selected person has an IQ below 90? How do I solve this question? First, in order for me to use the Z table, I need to normalize my distribution. Okay, now my distribution is mean 100 and standard deviation 16, I want to normalize it and make it a Z distribution. Okay, again, normal distribution with 0 mean and 1 variance. How can I do that, guys? I want this to be like this. This is going to be Z, mean is going to be 0, and variance is going to be 1. How can I go from here to here? How can I come up with a distribution whose mean is 100 and variance is 16? Now I want to normalize it. Okay, there should be a normalization. What does normalization mean? For example, there is one normalization approach. I will write the ages of the students. Let's say 19, 20, 21, 19, 22. There is another 25. Okay, there is another student, 18. Okay, I want to normalize this. One of the ways to normalize this, writing the minimum as 0 and maximum as 1. Okay, how can I do that? How can I go from 19, 20 and other things and change it to 0 to 1? How can I do that, guys? Hadi bakalım. I have 19, 20, 21, 19, 22, 25, and 18. I want to go from this distribution. Now I want to write the minimum should be 0, maximum should be 1, and everything in the middle should be normalized accordingly. How can I do that? Any ideas?
Hocam, I was supposed to use the Z table.
No, you're not supposed to use the Z table yet. It's just one simple question, right? You have numbers here, and I want you to change the numbers like it's 18, 19, 20, 21, 22, and 25 now. It should be like, it should write 0 instead of 18, 1 instead of 25. And for example, for 22, it will be 0.8. For 19, it will be 0.2 or something like that. Okay? Is this clear? So you're going to change, normalize. For example, we want to normalize the ages of people, right? If you subtract 18 from the whole group, let me sort this: 19, 20, 21, 22, 25. If I subtract 18 from all of them, what would I get? 0, 1, 1, 2, 3, 4, 7, right? This would be 0 would be 18, 25 would be 7, right? Then what should I do? Divide everything by 7. Now I have 0, 1 over 7, 1 over 7, 2 over 7, 3 over 7, 4 over 7, and 1. Now my 18 to 25 data set have been changed into 0 to 1 data set. This is called a way of normalization. One of the approaches. Is this clear, guys? Normalization can be done like that. For example, one solution is this. You have data between 18 and 25, and you want to make it from 0 to 1. How do you start? Subtract everything, subtract 18 from everything, so that 18 will be 0. This is the minimum value. So the maximum value will be 7. If you divide everything by 7, then it will be, this is going to be 0, this is going to be 1, and in the middle, the other values will be sorted or will be ranked accordingly, and it will be 1 over 7, 1 over 7, 2 over 7, and so on. Okay, is this clear, guys? Did you understand what's going on here?
Yes, hocam.
Okay, so let's come back to this question then. So I have this normal distribution of 116 square, and I want it to be normalized as Z distribution or normal standard normal distribution as 0 variance, 0 mean, and 1 standard deviation or variance. How do you go from here to here? If you subtract 100 from each data point, what do you get? You're going to get 0 mean number. You see, guys, 1, 3, 5. If you subtract 3 from each, 3, 3, 3, what do you get? -2, 0, 2. Now my mean became 0. If you subtract from all data points your mu value, you're going to have 0 mean distribution. If you subtract the mean of your distribution from all data points, you're going to get a 0 mean distribution. Is this clear? 0 mean distribution. Okay. So then if I divide everything by the variance or standard deviation, okay, if you divide everything by standard deviation, you're going to change this into events 1 standard deviation distribution. Here is how we do it. Okay, let me tell you once again. Z is going to be equal to all x values minus mu divided by sigma. This is how you standardization of Gaussian distribution or normal distribution. Okay, so if you come back again, let me tell you. Now go back to MATLAB. Here I had this distribution. Here is my distribution. His A. Here is my distribution. Where is it? Okay, this is my distribution, which is 100, which is changing between 15 and 90. And I know that the distribution has 50 mean and 10 variance or standard deviation. Okay, so how can I go back to my original distribution? I can say A minus 50. That will make everything now 0 mean, divide by 10. Okay, and then plot. Let me open up a new figure and then show you the histogram. Okay, now the distribution is 0 mean, 1 standard deviation. Okay, so it was 50 0 mean and 10 standard deviation. Now it is 0 mean, 1 standard deviation. How did I do it? I subtracted from all numbers the mean, divide by the standard deviation, okay, and obtained a new random variable. And if I show it like that, the distribution will be something like that. Out of 10,000 numbers, like what is the probability? Arkadaşlar hadi bakalım şöyle bir soru sorayım size. What is the probability that, how can I find the probability of obtaining a number which is greater than, let me look at here. Okay. How can I do it? Let me take it away like that. Okay. So this is my distribution. Okay. How can you find out the probability of obtaining a number which is greater than 2? How do you determine a number from this distribution, B distribution, okay, B data set? How can you determine the probability of obtaining a number greater than 2? How do you do that using MATLAB? Here is your distribution. How do you do that? If you count the number of numbers which are greater than 2 and divide by 10,000, you're going to get the probability, right? So find B greater than 2.0 and divide by, and I should also find out the length of this vector, and it found that it is like 202. 202 of these 10,000 values are greater than 2. Okay, so if I divide this by 10,000, this is the probability of obtaining a number greater than 2. Okay, if you go and find out this, find less than -2, it is going to be very similar. Okay, because this distribution is symmetric. The probability of obtaining a number greater than 2 is almost equal to the probability of obtaining a number less than -2, because it's a symmetric distribution. Okay, Gaussian distribution, normal distribution is symmetric, or standard normal distribution is symmetric around 0. So this probability can be seen from Z table, right? Let's take this Z table. If MATLAB has this Z table thing, okay, it's something else, I guess. Table, it's Z table is not found here, but there should be one solution. Let me find out here, for example, -2. -2, here it says the probability is 0.0228. What did we find? It was 0.02, 0.00020. Okay, so this is what we found. Okay, this is what we found as the probability using just the data points that we had. And here is the Z table. What it says is 0.0228. We found 0.00202. Here 0.0216. Okay, it's almost the same thing. Arkadaşlar, burası anlaşıldı mı acaba? Ne yapmaya çalıştığım bilmiyorum. Biraz hızlı mı gidiyorum ya da biraz karışık mı anlatıyorum ama so there is a distribution. Okay, it's called normal distribution. It has two types. One of them is standardized Gaussian distribution, which has a bell shape and which has a mean value of 0 and variance, or the standard deviation, being 1. But you may have data points. Okay, you may get data points from your EEG, from your sensor, from economics data, anything like that. You may have a distribution whose mean is 100 and whose standard deviation is 16, like an IQ curve. Okay, and among the citizens, among the people, some people have lower IQs, some people have higher IQs. That's what the studies show. Okay, let's say IQ is a standard test which may be biased, which may not be the exact exactly the greatest thing to find out the IQ of a person, but it shows something, let's say. And then you want to find out the relationship between, let's say you want to go out and say, what's the probability of obtaining this person being a genius, which is greater than 140 IQ, which is lower than 90, which is like under, let's say, intelligence level, IQ level is a little bit lower than the normal population. Okay, that's why you can find out those kind of things. So if you have this, let me go back to here. Okay, if you have this distribution, like that, okay, it's not working. If you have a distribution like this, okay, can you see my mouse? Can you see my cursor, guys? Yes? No? Can you see my cursor on the screen? Arkadaşlar, you cannot see it. Ne oldu buna? Bir dakika, bir tanıştırma yapalım tekrar. If you have such a distribution for the IQ, then you can go from here to here and use the Z table to find out the probabilities, okay? That's what we have done here. You have 90 as your IQ, 90 and below, and your mean is 100. You take 90 minus 100. This was your formulation. Divide by the standard deviation and obtain minus 0.63. What do you do? X less than 90 is my question. Now it is Z less than minus 0.93. This is, okay, this is normalization or standardization, let's say. Normalization or standardization. Because why do we need that? Because you have the Z table and you want to be able to make use of Z table. How can you use it? You have to standardize your question into a Z distribution, okay? From a normal distribution to a Z distribution. Z distribution is the standardized form of your normal distribution, whose mean is 0 and standard deviation is 1. Then in your Z table, you can find out either probability of Z less than 0. minus less than 0.63 or 1 minus Z, or like probability of Z greater than 0.63. As I said, because of the symmetry, you may use these both probabilities because the distribution is like this, okay, and 0 and 1. It is either this area or this area, okay? This is 0.63. This is minus 0.63. The areas are probabilities. Probability of Z greater than 0.63. This is probability of Z less than minus 0.63. Same thing, okay? These are equal things. Now, I want you to do this question right now.
John, where did we get 0.7 from?
What's that?
If we scroll just one slide, yeah, where did we get 0.73 from the probability of Z less than?
This is the Z value that we are going to use, okay? This is the Z value, this 0.63. And we use this 0.63 in my Z table, okay? I go to the Z table and check which, what is the probability of, what's the probability of obtaining a Z value less than or greater than 0.63. Okay, I check it from the Z table. So this is how did I find minus? Is that your question, Aminan? How did you find
so
this?
No, 0.7357. The probability of Z less than 0.60. Yeah.
This one, yeah, I found it from the Z table. Okay, if you
Okay.
check, let us do it if you want. Okay, can you see my screen? Z table. Okay, this is my Z table, and I go to this. I go to this Z table. Okay, and what was the number? 0.63, right?
0.63.
So
Yeah.
how do I determine 0.63? This is minus 0.6. You see this? You see this part? 0.60 minus 0.6. Okay, and you go to the third column. You see there is a Z column. 0.00, 0.01, 0.02, 0.03. You try to find out minus 0.63. So it will be minus 0.63. Let me copy this, but I cannot do it. Okay. So let me explain this to you on my. So here is the table. Okay, there is Z 0.00, 0.01, 0.02, and so on. Okay, and there are minus 3.4, minus 3.3, minus 3.2. Okay, for example, if I want to find out the probability of Z less than minus 3.21. Okay, let me write again. Z less than minus 3.22, let's say. How do I find the probability? I go to the Z table and find out this row and this column and find out the number here. Okay, this number is going to be the probability of Z being less than minus 3.3. Okay, this is how I found this number. Sometimes it is minus plus, so you should be careful on using some Z tables. So you will be becoming more accustomed to using Z tables, but this is the main logic. Okay, if you check the Z table, it has one row like that, it has column like that. How do you find a number? You start from here, minus 3.3 or 0.6, and you want to go to 0.03. So here is your number, 0.6, and put this next to it, 0.63. Okay, so this is minus 3.22. This is minus 3.33. Okay, this 3 comes next to this 3. This 3 comes next to this 3, and here is the number that you're going to find out. Okay, so if you check this at home, once we finish the session, you may check this Z table on your like alone. Okay, so let's go to this question. I want you to find out the probability of, you can check the Z table again. What's the probability that a randomly selected Kayserian has an IQ above 140? What's the probability of obtaining a person, randomly selected person in the population whose IQ is above 140? Okay, it's your time. Tell me the probability using the things that we discussed above, and then the Z table that you're going to find out from the from the internet. Okay, so I hope something has made some sense. Let's have a 5-minute break at this point. Arkadaşlar, let's meet at 10:20 and then continue with statistics, okay? Okay, this is the statistics part of the course. Until now, we talked about probability. We talked about random variables, probability distribution functions, probability mass functions, cumulative distribution functions, expected values, variances, and so on. So, and probabilities from random variables and their distributions. We had different distribution types: exponential distribution, normal distribution, like from the continuous random variables, in discrete random variables, Bernoulli distribution, Poisson distribution, and so on. So we had different distribution types, okay? So these distributions of random variables will be important for the statistics part. Random variables are usually our data points, arkadaşlar, data points, okay? As engineers, we always deal with data. We may have internet-related data, we may have sensor-related data, we may have patient-related data, all types of data points that we may have, we may be using, okay? For example, as a biomedical engineer in biomedical engineering field, you have points, data points from patients, okay? Either as a time series data points, okay? Their time series data, for example, their, let's say, breathing cycle is changing, their heart rate is changing, okay? 90, 85, 80, so this is heart rate. And for example, the person's blood sugar level may change with respect to time. Okay, you may get from some images, some numbers related to the image, related to the cancer, for example, how much the cancer has developed or has progressed so far. So we always have data points, okay? We may have sensors on the person, and it may give us some indication of the movement of the person, or like falling of the elderly person. So these are all data points, okay? And here we want to find out, we want to do some statistical analysis on them, okay? In this part of the second part of the course, we will be mainly focusing on statistics, okay? What does statistics mean? We will try to give you a sense of what is statistics as we go further, okay? So here is one example, okay? For example, we wanna find out certain things, okay? We wanna find out the average blood pressure of the population. We wanna find out the purchasing habits. We wanna find out internet use of people. We wanna find out mean age or median grade of a person, okay? GPA of the whole university students. So here we are trying to find out information from the population. For example, Turkish population or world population, or only the doctors, only the elderly people, only the students, only bacteria, okay? We want to find out something about the whole population. But also we may be interested in comparing two or more populations, okay? For example, we want to compare the population, the average blood pressure in men and women, average, let's say, purchasing habits of men and women, let's say, calories consumed with athletes and non-athletes. We want to be interested in certain property of a population with certain trees, for example, or certain bacteria, or different diseases, normal people and diseased people. We want to be able to compare two populations. Okay, in this course, we will be able to find ways to find out a certain or estimate, we call it, estimate something from the population. Okay, this is my population. Let's say we have 3,000 August students or 4,000 August students, and I want to find out, let's say like how many hours do they sleep. Okay, I will not be able to go and ask 4,000 students how many hours do they sleep, how many hours sleep, okay, do they have each night. Like, for example, someone will say I sleep 3 hours a day or 10 hours a day or a night, 5 hours a night. Okay, there might be some what am I interested in? Average sleep time or sleep duration, for example, of August students. Okay, so that might be my question. Average sleep duration of August students. I will not be able to have all students giving me an answer to a survey that I prepared, but maybe I will be working with only 100 students and obtain their answers from a survey. And then from that survey, I will be able to find out the average sleep duration. And I can also say this is the stand mean or stand average and the stand deviation from this 100 student group. Is it the same thing, like 4,000 students and 100 students? They're not the same. But either I don't have enough answers from all students, or I cannot go and ask that many students because I don't have enough time, I don't have enough resources. For example, if I'm interested in something from the Turkish population, let's say 85 million people, I cannot go and ask each and every 85 million person in this about something, right? How much do they spend every day? This might be an interesting question, but I may not be able to go and ask each and every person in the population. So I choose a subset of the population. Okay, we will call it random sample. Okay, it will be a sample. It will be a sample set, and then we may be, after finding the average of something, median of something, variance of something, or compare two groups. For example, how many hours male students sleep, how many hours female students sleep. Is the difference between them is significant? Okay, is the difference between male and female students in terms of duration of sleep different? Significantly different, statistically significantly different. Okay, we will all use these kind of issues. Okay, here we will be estimating averages, means. Okay, estimating averages or proportions. Okay, proportion. For example, what is the proportion of students having smoking? What's the proportion of students having a bicycle? What's the proportion of students, let's say, staying in a dormitory? What's the proportion of students or people who are eating carbohydrates this many days of the week? Okay, so these can be something related to proportion. We may be interested in averages or means. We may be interested in comparison of these proportions or averages. Okay, comparison. So these are the things that we will be discussing in this part of the course. And we will have data points. Okay, we will have we will try to find out the appropriate, let's say, random sample, and then come up with an average sleep duration. For example, in the elections right now, they are trying to estimate who will win, right? The presidential election. They don't go and ask 65 million people who will vote for the elections, but they go and choose 3,000 or 4,000 people or 10,000 people, but try to select those 10,000 people which will be representative of the Turkish population, people from villages, people from different education levels, people from different ages. Okay, a good random sample which is going to be a representative of the whole population, and you try to come up with some estimates, some predictions. Okay, that's the main idea of statistics, actually. So you may find out proportion of what's the proportion of people who's going to vote this candidate or that party. Okay, so again, this is something which cannot be told from now. We have still some time for the whole election, but we may do some polls, we may do some surveys in order to understand what's going on in people's minds. Okay, so you are trying to learn something about the population, but you cannot go and ask every individual in the population, every person. So you select a random sample, and then from this random sample you try to draw conclusions about the larger population. Okay, so these data points, these measurements will help me to draw conclusions about the larger population. Okay, for example, I am producing 100,000 let's say TV units. Do the testing people in the factories do the checking to each and every unit? No, they just sample certain number of units, and they check those units from that lot. For example, that day 1,000 units have been produced. They choose, let's say, 15 of them, and then do the tests and find out if there is any problem in this lot. Okay, so the critical thing is we cannot go and ask, and we cannot go and test, we cannot go and measure, we cannot go and get information about something from all the stakeholders, from all people, all bacteria, or all trees, or all factories, but we take a random sample from the population and we try to draw conclusions about the larger population. Okay, for example, let's start with a question like that. Okay, this is the statistical digital statistical indicator of this year. There are more than 85 million people in Turkey, and 71 million or 71 million people have internet in their homes or in their cell phones or any place like that. So here's my question. Okay, what proportion of Turkish internet users are addicted to the internet? Here's my research question. Let's say I am a psychologist and I'm interested in the internet addiction problem. And I have these numbers, 85 million, and 71 million of them are using internet. So I should be able to say something about over 70 million people, right? So please write to chat, and this will be another quiz for you. Okay, this chat will be another quiz for all the individuals who are attending the class right now. I want you to tell me what kind of a strategy you would use to find out the proportion of, or estimate the proportion of the Turkish population, but not the whole Turkish population, internet users that are addicted to the internet. What would you do as a researcher? Let's say you are a researcher and I want you to do a research on internet addiction. How will you, what kind of things you would do to find out or to estimate the proportion of Turkish internet users that are addicted to the internet? Okay, please write to chat, and then this will be another quiz for you.
Okay, so first you have to define addiction. Okay, internet addiction. So you have to define internet addiction. What does it mean? Does it mean this many hours if people are on internet? Does it mean that they are internet addicted? Maybe not. Here are some things that psychologists have come up with. If you are using the internet to escape from your problems, then you tick that. If you trying unsuccessful to cut back the usage, for example, you are trying to stop using internet or your cell phones, but you cannot stop doing that. Okay, then you check it, and you find yourself preoccupied with the internet when no longer sitting at a computer, even though you are not on a computer or you are not using your cell phone, you are still thinking about those kind of things. For example, my son, he likes to play video games on his computer. Even though he stopped doing that, he comes and talks about it all the time. Okay, so that means this preoccupation. So he is really busy with what he has done in that thing. First, so define internet addiction. Maybe you can go and talk to an expert on that. Okay, so why do we need that? We need to come up with a certain survey questions. Okay, survey questions. So you cannot say, are you an internet addicted person? No. Yes. No. No. It's not the way it is, right? You have to ask proper questions to understand that person is an internet has an internet addiction problem. So you have to come up with a survey, prepare the survey using an expert. Okay, come up with questions which will reflect the understanding of the population having an internet addiction. So start selecting a sample, okay, which is like, let's say, a certain number of people from the whole 70 million people. So it should be, let's say, 3,000 people. You can use face-to-face surveys or online surveys, okay? And then this 3,000 answers will come. And then according to your answers, you're going to say the first person is addicted, the second person not addicted, third person not addicted, fourth person not addicted, and so on. There will be 3,000 answers, okay? And after these 3,000 answers, let's say 100 of the people are checked. The remaining 2,900 people are not checked. Okay, that means these 100 people are addicted. The remaining is not addicted. And you say, out of this 3,000 people, 100 people are addicted. So it is around 3.33% of the population is internet addicted. Okay, but you have to also come up with some confidence intervals, which we will talk later. Okay, so did you understand how I should proceed about the problem? So you should first define the problem. Okay, define the problem, and then come up with survey questions with the help of experts. Then you should choose a sample with a random sample. Okay, it should reflect the internet users. Maybe you may want to focus only on young people. That's your solution. That's your selection. Okay, you may say, I'm only interested in high school students or university college students. Then you may focus on more into a subset of the whole population. Okay, so is this clear, guys? it is not about only asking people whether they are internet addicted or not. If I were to come up with a research question about what is the percentage of bicycle usage in Agü campus, let's say, that means what's the percentage of people who have bicycles at Agü, then it's going to be easier question, right? Then I will say, do you have a bike or not? Yes. Do you have a bike or not? Yes. Yes, no, no, yes, yes, no, no, yes. Okay. So then I can come up with a proportion easily. But when it is about the internet addiction, it's not that easy. People will not say that they are addicted to internet. There should be an indirect way for us to understand that person is having an internet addiction problem. Okay, so please make sure that you understand the problem, you understand the research question, whether it is like you have to collect data directly by asking people whether you have this, whether how much you pay to this, how much you spend each day, how much you sleep, what's your heart rate. Those kind of things are maybe directly can be answered by people, but some things need some extra pathways to collect the data. Is this clear, guys? Do you understand what I'm talking about? Okay, so I hope you got the main idea here. So in the previous case, you find 179 people with addiction problem out of 3,000 people, and like almost 5.7% of the whole population is estimated to be to having an addiction problem to the internet. Okay, again, P hat is an estimation, okay, or prediction. Why is it estimation or prediction? Maybe it's not the exact, it's not the correct proportion. Maybe you selected a wrong sample. Maybe you are overestimating or you are underestimating. Maybe it's like 10%, but you are finding 5%. You see, from the elections, there are many different answers, right? Some of them says this, some of them says another thing. So even though they ask to the population, like a sample from the population, they may get different predictions. That's the statistical or randomness. That's where the randomness comes into play. Okay, randomness. So statistics should be related to randomness, right? There should be a randomness in the process. You cannot just say, oh, it's like, what's the average GPA of students? You can go and have an UIS account, which will be easy for you to ask Fikri Bey to tell me what is the average GPA of Agü students. I can do that. But what's the average GPA of all college students in Turkey? It's not easy. You have to sample from different universities, from different levels, first year, second year, third year, fourth year, even some longer duration staying guys. You have to ask them, right? So it's very critical for you to come up with a sample statistic which will summarize your data. Okay, so in your final project of this course, you're gonna come up with a research question, guys. Okay, research question. Either you're gonna perform a survey, or you're gonna use a data which is already available in Kaggle, in other resources, and come up with some research questions and some of the estimations or predictions that I will want you to do. Okay, this will be the term project, which is the highest thing in this course. Okay, so do you understand the population term? The whole population, the whole people, the whole Agustinus, all young people, all people who are above 65 this is a population, okay? It doesn't mean population of Turkey. Population means you are focusing on let's say a subset of something. For example, let's say trees in Kuwait, okay? Fish in Trabzon, okay? So this can be a population. What is the thing that we found as p hat is the parameter, okay? This is going to be an estimate. What are we trying to do? We are trying to estimate the real population parameter, like the real proportion, the real addiction, the number of people who are addicted to the internet. That's what I'm trying to find out, or the percentage. But I cannot find it directly. I can only estimate it. So that's why we have population parameters like the mean, like the difference between means, population variance, population proportion, the difference between two populations. But we only do sample mean, sample differences, sample variance, sample proportion, sample difference between proportions, okay? So the things that we are finding out are sample statistic. What is the thing that we want to find out? Population parameter. But we can only find out this and draw conclusions about this, okay? We found the p hat as being 0.00757 as my estimate, okay? Or 0.057 as my estimate. This is like 5.7% of the population is the internet, it has an internet addiction problem, but we don't know what the real population proportion, and we want to come up with a good estimate with some confidence intervals, which we will start talking about these next week, okay, inshallah. So in this course we will be dealing with research questions, we will be dealing with data, we will be dealing with sample statistic in order to find out means, variances, proportions, differences between proportions and means. And then we will find out different approaches for different distribution of data. So this is what we are expecting for the next couple of weeks. I hope that you're going to enjoy this statistic part, and we will start going into more details next week this time, inshallah. Okay. Any questions, guys, you want to ask at this point? So it is the end of the session. Thank you for coming, and hope to see you next week.